matches. So output will be like the and SSN, DNO, D number, and name. 1 1 1 2 2 2 3 3 3. 1 2 3 1 2 3 and name. Okay. This is the join operation. What if the manager asks, why don't you retrieve the all employee and whose department information? All employee, but 444 is not here. So you need to union with this one. So it's 2 times of implementation. Instead, I'd like to include all of left hand side, and in case of non-match data, null, null, null. Okay? This is called left outer join. Left outer join means include all the data left hand side, then match data from right hand side. Okay? To differentiate from the normal join, we can use this symbol. So from join, left hand side, left outer join. Similarly, the manager asks all department information and whose corresponding employee, most likely. Okay, all right hand side, which means we have 4, the external pair. And what about this? It should be null, null. This is the right outer join, right hand side. So this will be like this one. So this will be like the right outer join. The last one is both the side. So which means 444 null, null, null data. This is a full outer join. And symbol is like this. Full outer join. The normal join is only matched one. Left outer join, all data left hand side, then matched one. If not matched, it's a null data. And right outer join is all data from the right hand side and match it, yes, not matched, no, just null. And both sides is a full outer join. These left, right, full outer joins are fully implemented in SQL also. We will practice during the SQL and exercise one. This is the types of the join. So these are the examples of the query. So we will see quickly some of the examples. So retrieve the name and address of all employees who works for the research department. First, you need to do, when you convert this plain text English to the relation algebra, you need to decide first data source, relation name first. Where can you get the name and address? Employee. So you need to access the employee. And also, where can you get the research information? It's the name of department. Name of department only in department. So you need to access the 2 relations, department and employee. Then there are different ways to implement this one, as we have seen. Let's see this example. First, research department. We can get the DNO. Okay? We can find the DNO of the research department. Here, research department temporary relation. Then join with employee. Join condition is D number of the research department and employee DNO. So change it. Okay? Employee DNO. So it has the DNO is equal to D number. Then we can get the research employee. But we need to what? Finally, we can apply the projection. So this is the final output. The project, first name, last name, and address of the research employee. Somebody may be curious. I don't want such a complicated one. Instead, employee join with DNO is a D number department. Okay? Then D name is research. Then project. Totally fine. Also, I wanna do the research department, DEPT. The name, D name is research. Okay, first. Then join with employee. Condition is the same, then projection. There are many different ways. Okay, the only difference is the performance. Okay, during the sequence. Next, retrieve the name of employee who have no dependent. What does that mean? There are two types of employee who has dependent, who are single. So we try to retrieve the single, the employee. How can we get the single employee? We can get the employee who has dependent from dependent table. Okay? Dependent table has an ESSN. So why don't we get such a ESSN from dependent? This the employee who has dependent. And all employee SSN. This is the employee. This is the dependent. No dependent. Dependent. This is the dependent. So we can minus. So we can minus all employee minus employee. At that time, type comparable. That is the reason. Only in this case, the project SSN and ESSN. Then we need to retrieve the name. So because of that, we can apply the natural join, but I think we'd better use the join condition. That's more clear. This is the way. Okay. Next class, I will show you some more example and also some other types of such a representation of the relational algebra operation and relational algebra expression. Okay. Meanwhile, because it's too long, the homework is 8.17 exercise. It's converting the plain theory in English to the relational algebra. It's a practice. In addition to your homework on Canvas, this is another the practice for you guys. So this one should be submitted to the classroom. Okay? So why don't you bring your answer in the next class? Next class is on Monday. Monday, why don't you bring? And it will be good, the practice for you. Then, if you want, you can enhance your page 2 project. There's no penalty if you change and modify, then you can resubmit. Or if the Canvas is closed, contact the GA. You can send the message or the email, then he will take care. Any question? More important thing is practice. Understanding concept is one of the huge benefits of the relational model is simple, easy to understand. Problem? In real life case, not easy, so you need to definitely practice. Yes?
Can you upload the exercise question on the Canvas because
GA will take care just in case. Okay? I cannot provide directly copy of that. It's a maybe issue. So why don't you contact GA? We already discussed, so GA can handle or help you guys. Okay? But first thing is, you do better have the text. Okay, that's the first rule. Okay, any other question? It's on the Canvas. Yes, it's a chapter. I will check the chapter number because in new edition it's a little bit mixed up. I will check it again. Okay, but anyway, if you click some of them, you can find it. Any other question?
That exercise is from the book, right? That exercise that is only...
It's a textbook. Okay, you don't have to submit on Canvas. Okay.
No, but the exercise is on the book, right?
Yes, it's an 8.17. It's an airline, I think, or something database. Any other question? Okay, thanks so much. Have a great weekend, even though it's Wednesday. Okay.